March 4th, 2018. It was a partly cloudy, lightly rainy day in Shenzhen, China. It was 68 to 69 degrees Fahrenheit. Maybe it was just an ordinary spring day outside, but for the world of 3D printing, that day was anything but ordinary. Creality was preparing to launch its new printer for sale. The images were uploaded to the website. The price was set. The countdown ended and sales began. No one realized it at the time, but this small desktop 3D printer would soon change the direction of the industry. That same year, it would reach sales of over 100,000 units outside of China, and later, those sales would surpass millions. Today, it is still one of the most recognized models among 3D printers. This is how the Ender3 legend, one of the most important milestones in the 3D printer industry, was born. Years have passed, but the Ender3 series is still among the most important series for Creality. Today we will be reviewing the Ender3 version 4 model. To be honest, it's one of the models I was most curious about, especially its design. Its other features, its technical specifications are also nice, but when you compare its design to other printers, it is definitely extraordinary. I won't drag it out. Let's first take a look at its design and examine its technical features. Then I'll continue with the prints I've made. I can say that the Ender3 V4 is the most stylish looking printer among all the Creality printers so far. There are no more vertical profiles. Instead, we now have this body made from a single piece of uniquely hardened aluminum, which really makes the printer look like a true piece of technology. Creality has stated that with this design, they not only aim to create a visual appeal, but also wanted to minimize the effects of vibration. Plastic material has been used on the lower part. In terms of material quality, it has a nice feel and appearance. With its curved corners, it has maintained the overall design integrity. On the lower right corner, there is a 2.8-inch color touchscreen. Its position and design are also nice. The interface is also user-friendly. However, if your hands are a bit large, you might have some difficulty using certain parts of the menu. As the build plate, a flexible spring steel PEI-coated bed has been used. With this print bed, we can print objects up to 220 mm in width and depth and up to 235 mm in height. The bed movement takes place on steel shaft guide rails. Leveling is done automatically. The nozzle touches multiple points on the bed, and the pressure-sensitive system adjusts the height at those points as needed, making it easier for the user to achieve a flawless first layer. The print head features a dual-gear direct drive extruder. The nozzle used is a type called Quick Swap by Creality, which combines titanium, copper, and hardened steel materials. Creality truly lives up to the name Quick Swap here. Nozzle replacement can be done very easily in just a few seconds. The print head moves along the x-axis on a steel linear rail. On the z-axis, there is a combination that I am seeing for the first time. Next to the trapezoidal lead screws on the right and left sides of the frame, a steel shaft guide rail system has been added, just like on the print bed. CFS can be integrated into the Ender3 V4. You can use the CFS for color printing if you wish, or you can have the printer seamlessly continue printing with the filament in the other slot when one filament runs out. Additionally, if needed, you can connect 4 CFS units to the printer at the same time and use up to 16 filaments in a single print. The V4 has wireless connectivity. You can send the files you sliced via Creality Print to the printer remotely and monitor the print status thanks to its integrated camera. You can also perform this monitoring from your mobile phone or tablet through the Creality Cloud app. The printer has some really great features. Many innovations have been introduced in terms of both design and ease of use. We can say that only the CFS remains the same among these. It's the same system used in previous Creality printers capable of color printing. To what extent have these changes affected the use of the printer, and at what level is the print quality? Now, we will look at all of these one by one. Including this video, I have completed a total of 2 projects with the Ender3 version 4. In one of them, I compared cheap filaments with expensive ones in many aspects and examined their differences. I sought answers to questions like whether cheap filament is bad filament or if it's really worth buying expensive filament. If you haven't watched that video, you can access it from the tag above or the link in the description section. In this first video, I used nearly 8 kilograms of filament. Now, let's take a look at some of the prints I made in that video. One of the classic test models is the Benchy boat. I printed 8 copies of each model, because I compared filaments from 4 different price segments here, both from Creality and from other brands. The models I'm showing you now are prints made with Creality Hyper PLA. I didn't encounter the slightest problem with this test model. The surface quality was quite nice. You are now seeing a model that was shared as a ready-to-print G-code file inside the printer. It's a spatula that can be used to remove prints from the build plate. Since it has a circular finish on top, the layer lines are naturally noticeable. On the other sides, however, the print is completely flawless. There is a dragon model that I have now made my standard. Since I think it's a good test print, I make sure to print this model in all my review videos now. Because I print this model without supports, I can observe how much sagging there is or isn't. I observe possible problems such as whether any vibration effects have occurred in the indented or protruding areas, or if there is stringing at the sharp tips. Apart from this sagging that I consider natural due to the lack of supports at certain points, I did not encounter any problems on the model. By the way, the height of this print is 235 millimeters. So with the Ender3 V4, the maximum height you can print in a single piece is this. Another print I made is a version where multiple print tests are applied on the same model. The sharp protrusions you see at the top show whether the printer produces stringing or not. An extremely clean result has been achieved. Here, not only do we see how efficiently the printer's cooling works, but it also gives us insights about the nozzle and filament quality. The result here is absolutely flawless. Below the stringing area, there are also places where the printer bridges without support. There is some sagging in these areas. In the previous test I observed that this increased or decreased depending on the quality of the filament. Hyper PLA, on the other hand, was one of the filaments that sagged less. The right-angled sections underneath came out very clean. There is no deformation at all. One of the important points for me was the right-angled section. No support is added to the bottom part while this print is being made. Let's first look at the top side. There is no problem. It came out quite smooth. When we look at the bottom side, there are slight sags between 20 and 15 degrees. But I can say that this is a very good result for this test. On the side, there is a bridge test. Although there are slight sags on the two longest pieces at the very top, there is no sagging on the ones below them. Looking at these test results, I think the Ender3 V4 achieved quite a successful outcome. The printer especially produces waste during color prints. We will talk about this amount of waste in a moment anyway. I printed this kind of box to prevent the waste from scattering around. Again, it was a G-code file that I didn't set up myself, but was already available inside the printer. I was extremely satisfied with the surface quality. There isn't the slightest layer mark visible on the flat parts. Only in the sections where the printer slowed down due to the given settings, there was a transition in the filament from glossy to matte. This is quite natural as well. At this point, we're taking a short break in the video for a brief announcement. Actually, I'm not speaking English right now. In fact, I don't even know English, but thanks to Heygen AI, on a powerful artificial intelligence tool, I can deliver my video content to you in English. In fact, if I wanted to, I could even start speaking Spanish right now.
Quizá debería abrir un nuevo canal de YouTube para mis publicaciones en español.
Or maybe in Japanese.
日本人ってテクノロジーの面ですごく進んでるんじゃないの？もしかしたら新しい YouTube チャンネルも日本語でやるのもありかもね。
If you also want to publish your content globally like I do, you can use Heygen AI, which provides dubbing support in more than 175 languages. Let's pick up where we left off. Since the Ender3 version 4 has a hardened steel nozzle tip, it can print with some carbon fiber reinforced filaments. Carbon fiber reinforced PLA and PETG are examples of this. For example, this decorative cat model you see here, it is designed with low polygons. If you ask me, it's quite beautiful. It was printed with the carbon fiber reinforced version of Hyper PLA. Carbon fiber increases the rigidity of the material. Therefore, for some functional parts, carbon fiber reinforced PLA can be preferred over regular PLA. However, since I really like the texture of the material, I think it can also be used for decorative products like this. I am extremely satisfied with the quality of this print as well. There are two more prints. These are lighting stands. Again, the purple one was printed with carbon fiber reinforced PLA, while the green one was printed with carbon fiber reinforced PETG. I'll show you the layer lines up close right now. In my opinion, both of them are printed quite beautifully. The parts you see on the top of the lighting were printed in vase mode, and both of these are made from PETG material. Don't worry too much about the color coordination. I made these choices because these were the colors of the materials I had on hand, but maybe with more harmonious colors, these decorative products could have been produced even better. However, I am still quite satisfied with the result. Prints made with both carbon fiber reinforced PLA and PETG as well as with PETG alone are quite good. So what should we do now? I want to leave the colorful prints for last. Let's first finish the colorless prints and the other materials, because later on we will already be evaluating the colorful prints in terms of quality. I will be sharing important information here. I will also, of course, make a brief comparison with the printers that I anticipate you will want me to compare. So I want us to take a look at the prints I made with ABS and TPU. The print you see here is, in my opinion, a type that can be used a lot in summer and is suitable for printing with TPU. You can use this as a stopper on doors or windows, especially when you open doors and windows facing each other at home. There is a significant airflow. Doors and windows can slam shut. That's why this is a print made with TPU that won't damage either the window or the door, and at the same time it can prevent the door or window from sliding. The surface quality is extremely successful. It looks almost as good as if it were made with PLA. This is a TPU material with a hardness of 95A, and it is printed without using CFS. Because you can't print TPU using CFS, there are some special types of filament. Or there are very hard TPU materials like 68D. These can be printed with systems like CFS or AMS. But you can't print TPU filaments with a hardness of 95A or 98A using CFS. Here, I printed at a speed of 50 millimeters per second. Maybe the printer could have gone a bit faster, but I don't want to take too much risk. Because when the speed increases, situations like the TPU getting stuck between the gears can occur. 50 millimeters per second was a safe bet for me. I was satisfied with both the print quality and the TPU performance. The designer also modeled another part, thinking that maybe a rigid material could be added to the same print to increase its strength. I printed these parts here with ABS as well. This combination made more sense to me, because even if you use it in a window and it is exposed directly to sunlight, ABS is a logical filament choice to reinforce the material since it has both heat resistance and a bit of flexibility. You can also see the print quality up close. There are no problems at all. I'd like to make a small side note here as well. I know most of you watching this video already know this, but for those who don't, here's a very brief explanation. To print engineering filaments like ABS and ASA, we need enclosed 3D printers. This is the ideal setup. In fact, if the enclosure also has internal heating, you'll be able to work with these filaments much more comfortably. Why is ABS not recommended for open frame printers? Because the material doesn't like air currents. It requires a stable temperature environment. If this isn't provided, the edges and corners start to lift. Especially with tall prints, cracks can form between the layers. Even if none of these happen, the mechanical properties of the material can deteriorate. However, I always experiment with ABS on open frame printers, just like I did with the V4. What do I recommend? If you're going to print with ABS, don't buy a printer like this, but if you need to, you can still make small things like this. For example, I applied adhesive to the print bed. I usually prefer to use hairspray. After applying hairspray, make sure there are no open doors or windows in the room. In other words, there shouldn't be any airflow. If the room temperature is as warm and stable as possible, you can easily get prints like these. For example, what you see on the print bed right now is also an ABS print. In fact, let me try to remove it. See, it was difficult to take off. You might have even heard the sound. Here, the effect of the adhesive is quite important, and as you can see, you can get prints like this, small prints, without any lifting from the edges or corners, and without any cracking between the layers. Of course, for this, the features of your printer are important. The bed of version 4 can heat up to 100 degrees, and the nozzle up to 300 degrees, which is more than sufficient for printing ABS. I made these prints with Creality Hyper ABS. It's a great filament that won't give you any trouble with adhesion, just keep that in mind. Now let's move on to the color print tests. We just mentioned CFS. It's not a new technology. CFS has been used in many printers before this one. It has also been made compatible with version 4. I did a few prints to test both its performance and the amount of waste it produces. What you see here is a life-size replica of the World Cup. Of course, you can't print something like this in one piece with the Ender 3 version 4. It was a model that was split in half. The print was made in 2 parts and then glued together. I called it a color print, but of course there aren't that many color changes on it. There are only transitions between the gold and green colors at the bottom part. The rest of the areas are made up of just a single color. I'm quite satisfied with the surface quality. There isn't the slightest flaw on it. I can say it's a completely flawless print with no visible layer lines. You'll notice transitions from light to dark in certain areas. Especially in the middle and right at the ends of the globe, there's a bit of darkness. The reason for this is the type of infill I used inside the model. In the slicing software, there's an infill type called Lightning, and thanks to this infill, the interior is produced hollow in areas where infill isn't needed. When it comes to the parts that need to be closed on top, it gradually increases, almost like a lightning bolt, ensuring that the very top is covered smoothly. I use this in the middle and upper parts of the model. What did this give me? First of all, the print time was reduced and I was able to create the same object with less filament. The disadvantage, as you can see, is that when you print with light-colored filaments like this, areas of varying darkness and lightness can appear. But I especially prefer to use this infill for objects that I will use decoratively. As I'm filming this video, the last 32 matches of the World Cup are currently being played. There are some really great matches. I try to watch them whenever I get the chance. France is doing very well. Argentina and Spain aren't bad either. There have been some surprises as well. For example, Germany was eliminated by Paraguay yesterday. I think it was one of the biggest surprises of the World Cup. So, I also went with the World Cup theme. I printed 2 football player cards, and since we've come this far, I guess I have to ask the classic question. Ronaldo or Messi? I'll also write in the comments which footballer I like more. I want us to talk a bit about this topic in the comments as well. You can see 2 prints made with a technique called U-Forge. The designer has made many more football player cards like these. If you have a printer that can print in color, maybe you'd like to print them too. I'll share the link in the description section. Both prints are extremely successful. The most important point in U-Forge is that there aren't too many nozzle marks, and both of these prints turned out quite smooth. One of the biggest problems with color printers that have a single nozzle is waste. That's why, whenever I encounter printers with a similar system, I always print the same test model and compare it with the printers I've reviewed before. For that reason, I printed this Ninja Turtle model once again, as you can see. Let's first look at the print quality. The surface quality is no different from the previous prints. There are almost no flaws on it. It's a model with a lot of color transitions, so it also gives us a good idea in this regard. Even though there are very small details as well as large areas on it, I didn't encounter the slightest problem with the color transitions. CFS was already a well-functioning system. Now, with their newly released printers, it has become fully compatible. Usually on this print, I would see the effects of vibration mostly in the areas where the head section is. However, on this model, I can only notice minor vibration effects if I look very closely. Other than that, there is nothing negative I can say about the model. However, there is one negative situation. During this print, the printer stopped 5 times. It's a 49-hour print. Having it stop 5 times at different intervals becomes a bit annoying. If you're wondering why it stopped, it's because the CFS filament can't be pulled, or rather it can't be pushed. I checked and saw that it couldn't push the green filament. I told it to try again. It rewound a bit, pushed forward, and so on. The print continued. Again, there was no problem. Hours had passed in the meantime. It was the middle of the night. I'd gone to bed. By morning, I saw it hit that level again, back in the green. When it happened on the 3rd, 4th, and 5th times, I just couldn't make sense of it. Because the problem only occurs with a single filament. Actually, I'm an experienced user. I should have thought of this. In the CFS system, if there is a deformation in the spool, which happens quite often with cardboard spools, the more structural damage, crushing, or warping there is, the harder it is for the machine to pull in and retract the filament. However, with hard plastic spools or very well-made cardboard spools, you don't encounter any problems. Unfortunately, enclosed systems like CFS or AMS can be a bit finicky during printing. That's why I wanted to mention that if you encounter a problem like this, your first priority should be to check the spool. Now let's talk about the amount of waste produced in this print. I'm sure some of you are curious, especially when compared to the A1 or the Spark Xi7, does it have any advantages or disadvantages? Let's take a look at that comparison right away. In my recent videos, I compared the A1, Spark X i7, and Cobra X with each other. Let's add this printer to that lineup as well. You can already see the amount of waste filament and print times for the A1, i7, and Cobra X. When the same print was done with the Ender3 version 4 using the standard Creality print settings, it produced 720 grams of filament waste, 90 grams of which was the prime tower, and the print took 49 hours. I will share my overall assessment about this at the end of the video in a moment. However, I want to say this. For the Creality version 4, they didn't use expressions like color monster or speed monster, and as we've seen with this model, it really isn't one. Yes, the print quality is very nice, but there was a lot of waste produced. It's possible to increase or decrease this with the settings. You can do this on other printers as well. In other words, you can reduce it with the purging settings you make in the slicing software. However, sometimes no matter what you do, you can't go below a certain level. If you do go below that, then you might not get results this clean. The reason for this is actually related to the nozzle. On these other printers we mentioned, the nozzle distance is much shorter. The filament is cut much closer to the nozzle, and a small amount of filament is enough for cleaning. The unicorn nozzle, on the other hand, is quite a long nozzle. To perform this cleaning, more filament needs to be used. That's why more waste can be produced in color prints. This doesn't apply to this model, but there are some ways to reduce waste in 3D printers. For example, whether you print one of these keychain models you see here or 20, the same amount of waste is produced. As I said, this is an advantage if needed. It's a movable and quite fun keychain model in the shape of Bart Simpson. Since I only had one CFS, I could only use 4 colors. That's why I couldn't make the pupils. I'll draw them later with a pen. For example, if I had connected 2 CFS units, I could have made the black dots in the pupils with this printer as well. The surface quality is extremely successful. The spread of the models on the build plate was absolutely flawless, and all prints could be taken easily without any errors. Here you can see another colored print I made. In colored prints, especially the transition between black and white can sometimes be difficult. After all, there is a transition from the darkest to the lightest, and here, leftover filament inside or at the tip of the nozzle can mix together, which becomes a printing issue. I had printed 2 Panda models. There is a transition between black and white in almost every layer. However, there was no problem in either print. Both the black and white colors came out beautifully. The V4 is one of the best Creality printers I've used recently. In fact, I don't even want to limit this to just Creality. It's one of the printers with the best print quality I've used lately. Even though it's an older model, I imagine many people will want it to be compared with the A1. I can give a clear answer to that. It has print quality that's at least as good as the A1. It might not be quite as good as the A1 when it comes to noise. There's no problem with the bed movement, but when the print head moves side to side, especially during sudden accelerations, there was a noise that bothered me. This also affected the sound tests. In the sound test I did, using the standard Creality print settings, I got a result in the 50 to 53 decibel range. Still, I think it can be used comfortably, especially during the day if it's in a different room or at night when set to silent mode. The issue of remote connection has been completely resolved. I've seen this in other Creality printers I've reviewed recently as well. I haven't encountered any problems at all. I was able to easily send the slice models and track the prints without any issues. The camera also provided quite sufficient performance for monitoring. The time-lapse videos are of a quality that allows you to observe how the print is progressing. However, you shouldn't expect much more than that. When it comes to color printing, CFS is not actually a new technology. Yes, it is compatible with the printers and works nicely. Color prints come out clean, but they are inefficient. In fact, I mentioned this both for AMS and CFS when I first started using them. They work well, but they generate a lot of waste. Unless the number of nozzles increases, it doesn't seem very possible to reduce the amount of waste. In my opinion, it can be a good choice for those who won't do a lot of color printing and don't want to waste time changing filaments. If you don't need it, you can also opt for a plain version without CFS. Of course, the need for print area varies from person to person. When I first heard about the 220mm print area, it seemed a bit small to me too. But later during my test prints, I realized that it was actually quite sufficient. As I said, it depends on your needs. But I also know that there are quite a few people who don't want to dedicate a large space in their home or office to a 3D printer. Therefore, it will also meet the needs of those who want a more compact printer. I'm going to go back a bit, but I can say that since the CR6 SE, bed leveling has been the best automatic leveling that Creality has done. The CR6 SE is a legendary device that first introduced automatic leveling. It doesn't disappoint its users much. I never had any problems with prints that covered the entire bed. Afterwards, of course, I also performed a first layer test, and the printer did not let me down. I achieved a result that I can say was almost flawless. Changing the nozzle on the device is very easy. In fact, I don't think there's a printer on the market right now where you can change the nozzle more easily than this one. Yes, many printers have now made this process practical. For example, it was the same with the A1. You just remove a clip, but in that case it comes off together with the hot end. It's similar with the Spark X E7. On the Cobra X, the hot end cover opens like this. You pull the nozzle forward and so on. They're all easy, but this one is much easier. And the fact that the nozzle is independent from the hot end also reduces its cost. In that respect, it's one of the best systems I've seen. I think Creality will continue to use such systems in their future printers as well. In my opinion, it's an ideal printer for those who want to use PLA, PETG first, and later carbon fiber reinforced PLA, PETG, or even TPU. Sometimes I hear that gentlemen have trouble convincing their wives to bring a 3D printer home. I think you should show this printer to your wives, let them see its design, tell them its dimensions. It will make it easier for you to convince them. Likewise, ladies who want to buy a printer for their home won't have much difficulty making a decision once they see how elegant and stylish this printer looks on top of what I've already mentioned. To be honest, I'm convinced myself, because I haven't tested a printer for this long in quite some time. Of course, the first project also played a role in this, because I used almost 8 kilograms of filament and my thoughts about the printer became fully formed in my mind. I was very satisfied with the print quality and it never let me down during this process. Yes, that's all I have to say about the printer. I hope this video has been helpful for you and that I was able to give you an idea. I'm looking forward to your comments and any questions you may have about this printer. I would be happy to answer all of them. May your printer run smoothly and your prints be flawless. See you in the next video. Take care.